Assalamu alaikum. I welcome you to this new video on Hicksian and Marshallian demand functions and consumption duality. In this video, I'll explain a number of very interesting concepts and terminologies that you might have never come across before. So I hope this is one of the most interesting and most informative videos for students of MPhil and PG economics. So let me start with the consumption duality, and as a background information, we can say that an individual consumption decision has a dual nature, just like the firm's production duality. So consumption duality has two sides. One is the primal problem and the other one is dual problem. Consumption duality can be obtained either through utility maximization subject to budget constraint or expenditure minimization subject to utility target. We can either fix the budget and obtain maximum utility, and that is known as the primal problem, or we can fix the utility level and minimize the expenditure, and that is known as the dual problem. So on the left hand side we have the primal problem, and on the right hand side we have a dual problem. uh, on the left hand side, the budget line is fixed, it is given. We may have an indifference curve below this indifference curve, which is tangent, which has tendency with this budget line, that is where the budget line is tangent to this indifference curve at this point. We may also have indifference curve above this indifference curve. So the higher indifference curve cannot be obtainable, it is impossible given this budget line. And the lower indifference curve, although we can obtain with this budget line, but that will not maximize the utility. So this is the only equilibrium situation in which the consumer is maximizing utility subject to the budget constraint. On the other hand, here we have a number of isocasts, or you can say a number of budget lines for this consumer, and he has this objective to achieve. I mean, he wants to enjoy or consume this utility, to attain this utility level. So he has three budget lines: this one, the purple one, the green one, and the red one. Now this utility are shown by this indifference curve is not possible with this budget line, so we cannot attain this utility. We can attain this utility level either with this budget line or with this budget line. So if we are using this budget line, then we are not minimizing the cost. So the best situation is this: when the green budget line is tangent to the given indifference curve at this point. So these are the consumer primal and dual problems. So let us deal with this prime problem mathematically. We can discuss consumption duality using primal problem and dual problem, but we use a mathematical manipulation and mathematical approach. On the left hand side, we see that this is the primal problem of the consumer who wants to maximize utility obtained from X subject to the condition that the total cost or the total expenditure on X good, or X, where X is vector of X goods, is equal to the consumer fixed money income. And if we solve this constraint maximization problem, the solution value or the solution functions are known as a Marshallian demand function. And Marshallian demand function, as you can see from this equation, are function. They are function of the prices of all goods and the consumer budget or fixed money income, denoted by M. And if we substitute these choice values or these optimal values of x back into the original utility function, we get indirect utility function, which specifies utility as a function of prices and consumer money income. And on the other hand side, we have the dual problem, and here the consumer wants to minimize total expenditure on goods subject to some utility target that is equal to u bar. That is, the utility from x should be also should be either greater or equal to this utility level, which is given by u bar. If we also solve this constraint minimization problem, then the solution values obtained are shown by h, where h is function of p and utility level, and these are also known as Hicksian demand functions or compensated demand functions. Similarly, just like the primal problem, if we substitute these optimal values in the expenditure or cost of the consumer, then we get the cost function, and it specifies C, that is consumption or cost. It specifies cost as a function of prices of goods and utility. These equations have some tricks and similarities. We may also use Slutsky equation to relate Marshallian demand function with the Hicksian demand function. Now, in order to proceed further, if we substitute the indirect utility function into the Hicksian demand function, then we get Marshallian demand function. Can we also get Hicksian demand function from substituting the expenditure function into the Marshallian function? So for that, we need to go to another slide, and it says yes, of course. If we substitute the cost function into the Marshallian demand function, that is, if we substitute the value of m from this equation here into this Marshallian demand function, then we get Hicksian demand function. Furthermore, we can also go in backward direction from the indirect utility function, and by doing so, we can get Marshallian demand function from indirect utility function through Roy's identity, which can be used to derive Marshallian demand function from the indirect utility function, where Roy's identity is given by x, that is equal to the negative of the partial derivative of indirect utility function with respect to price divided by partial derivative of the indirect utility function with respect to income. Similarly, we can also go back in backward direction from the cost function through Shepard's lemma and Horting lemma, and if we rearrange, we get Hicksian demand function. So this means that if we take partial derivative of the cost function with respect to p, we get the Shepard's lemma or Horting lemma that can be used to derive Hicksian demand function. Similarly, if we take partial derivative of indirect utility with respect to price and hold utility constant, Then we get what is known as Roy's identity, which can be used to derive Marshallian demand function from the indirect utility function. Consumer or consumption duality can be thought of as a coin. Heads, the consumer maximizes utility to monetary constraints, and tails, the consumer tries to limit or minimize the consumption expenditure subject to a given utility level. Either way, the problem of the consumer can be solved easily. Let me also spend some time on linking demand functions mathematically. And first we relate Hicksian and Marshallian demand functions via simple identity with the help of a theorem. And the theorem says, suppose utility is continuous and suppose utility function is continuous and locally non-satiated, then number one, for all prices strictly positive, that is, the price factor including prices of various goods are strictly greater than zero, that is, they are strictly positive, and the consumer money income or the budget is non-negative, that is greater than or equal to zero, then the Marshallian demand function is equal to the Hicksian demand function, in which we substitute the value of the indirect utility function, and the expenditure function is equal to consumer money income if we substitute the value of the indirect utility function. And number two, for all prices strictly positive and utility is greater than or equal to some utility level, then the Hicksian demand function is equal to Marshallian demand curve in if we substitute if we substitute the expenditure function into the Marshallian demand function, and if we substitute expenditure function into the indirect utility function, then that is equal to the maximum utility. So this means that if indirect utility is the most utility that the consumer can attain with the income M, then consumer needs income M to obtain utility V, that is a function of prices, and M, which is the most utility. Similarly, if the amount of income equal to E as a function of P and some utility level is needed to attain utility U, that is utility target, then U is the most utility the consumer can obtain with the income given by E, that is a function of P and U. Similarly, using Slutsky equation theorem, we can also link demand functions mathematically. And this theorem says, suppose utility function is continuous and locally non-satiated, and let the price factor be strictly positive, that is, all prices are greater than zero, and consumer money income is equal to the total expenditure on the goods, which is a function of prices of goods and some utility level. If the Marshallian demand function and the Hicksian demand function are single valued and differentiable function, then for all I and j, the Slutsky equation is given by this equation, that is partial of xi, which is a function of prices and money income with respect to partial of j, that is equal to partial of the Hicksian demand function with respect to price j minus partial of xi, which is a function of prices and budget or money income with respect to income, times the amount of xj, which is a function of prices of goods and money income. Now this equation says that the term on the left hand side is the total effect, and on the right hand side the first term is a substitution effect and the second term is income effect. And Slutsky equation basically decomposes total effect into substitution effect and income effect. Now the intuition is, if price of the xj increases, it may have two effects on the demand for good xi. That is, if pj increases, there may be two effects on the demand for good I. So the first is a substitution effect, which is given by partial of hi with respect to partial of pj. Now this basically will show movement along the original indifference curve, and that basically is that change in quantity demanded is basically in response to a change in prices holding utility fixed. The second term on the second effect due to change in the price of jth good and the demand for good I has income effect, and that is equal to minus partial of xi with respect to m times quantity of j consumed, which is a function of prices and income. And income effect basically shows movement from one indifference curve to another. If you remember, substitution effect basically constitutes movement along the originally given indifference curve, whereas income effect shows movement from one indifference curve to another indifference curve, and it is in response to change in income holding all prices fixed. So this is how we can decompose total effect into substitution effect and income effect. We can also develop some terminologies for consumer theory using comparative statics, and we starts with the definition of various goods. Number one, good xi is a normal good if the Marshallian demand for good I or xi is increasing in income. So then in that case, xi is a normal good. Xi will be inferior if Marshallian demand function for xi is decreasing in income. So in the first case, xi is normal good if Marshallian demand function is increasing in m. If it is decreasing in m, then xi is known as inferior good. Then we may also classify goods as regular and giffen good. xi will be a regular good if the Marshallian demand function for good xi is decreasing in price of xi. That is, uh, its own price will have negative effect on its quantity demanded. It will be considered as a given good if the Marshallian demand function for xi is increasing in its own price. That is against the law of demand. Similarly, good xi is a substitute for good xj if the Hicksian demand curve or Hicksian demand function is increasing in price of xj. So, if the Marshallian demand curve for xi is increasing in the price of xj, then xi is a substitute for xj. It will be a complement if the Hicksian demand function is decreasing in the price of xj. So this is how we classify goods as substitutes or complements. Good I is a Grad substitute for good j if Marshallian demand function is increasing in price j. It is a Gras complement if Marshallian demand function is decreasing in price of xj. This is very interesting. So there are certain remarks from the above analysis. Both the substitution effect and the income effect can have either sign. They may be negative or they may be positive. Substitution effect is positive for substitutes and negative for complements. So, if the sign of the substitution effect is positive, then the two goods are substitute. If its sign is negative, then they are complements. Income effect is negative for normal goods and positive for inferior goods. So these are very interesting lessons learned from this presentation. By symmetry of Slutsky matrix, xi is a substitute for xj and j is a substitute for xi, so that is symmetry of the Slutsky matrix. But it is not true that I is a gross substitute for j, that is xi is a gross substitute for xj, then it may also apply, but it is not true that xj is a gross substitute for I. So it means if xi is a gross substitute for xj, then it is not necessary that xj is also a gross substitute for xi. So income effects are not symmetric like substitution effect. So this means, in a conclusion, we can say that substitution effects are symmetric, whereas the income effects are not symmetric. Ladies and gentlemen, in this video, you learned a number of different things. The consumer primal problem, dual problem, utility maximization subject to budget constraint, expenditure minimization subject to given utility level, then derivation of Marshallian demand function from the constraint maximization of utility subject to budget constraint, and then we got the indirect utility function by plugging the choice values or the optimal values of the Marshallian demand functions in the original utility function. And conversely, we also saw that the constraint minimization of expenditure subject to utility constraint, we get the Hicksian demand function, and if we plug the optimal value of the Hicksian demand function in the expenditure function, then we get the cost function, and we can also get the Hicksian demand function by plugging the cost function into the Marshallian demand function. Similarly, we can also derive Marshallian demand function by substitution the indirect utility function into the Hicksian demand function. And finally, we also saw that in a backward direction we can take partial derivative of the indirect utility function with respect to pi and holding utility constant. We get the Roy's identity, which can be used to get Marshallian demand function. Similarly, getting back from expenditure function, we get the Hotelling lemma or the Shepard's lemma that can be used to get Hicksian demand function from the cost function by taking partial derivative of the cost function with respect to pi. And then we use the various theorems, that is the Slutsky theorem and the simple identity to relate Hicksian demand function and Marshallian demand function. And finally, we use that analysis to classify goods into substitutes and complements, gross complements and gross substitutes and inferior goods, normal goods, giffen goods and regular goods. So I hope this was quite interesting and quite informative. Ladies and gentlemen, in this video I have I have basically combined detailed information from various sources just in one video. So I hope this was one of the most important and most informative and most interesting video for all of you. I hope you liked it. Thanks for watching this video. If you haven't yet subscribed to the channel, kindly subscribe to the channel and don't forget to click on bell icon so that you can regularly get information and notifications about my new videos that will be uploaded for you. I thank you for watching this video. Thanks for watching this channel. Kindly share various videos of this channel in various WhatsApp groups so that these could reach to the maximum possible number of people. Thank you and see you in another video very soon.